So now we have the 555 timer integrated circuit here wired in astable mode. So you can see we have a blue and a red LED that are flashing there. They're just going to keep flashing as long as we have power applied. So that's why it's astable. There's no stable state. Neither one of these is going to stay on. I'm not doing anything other than I wired it up. It's just going to keep bouncing back and forth right there. So let's look at the schematic I drew first. And we have to power the integrated circuit, pin 8 positive supply, pin 1 to negative supply there. And then we need to disable pin 4. So that means we're just basically telling it don't do anything. And so you put that to the positive supply. It's waiting for a low enough voltage. I think it's like halfway to ground. But in case you put it to the positive supply, it doesn't matter. That's as far away from ground as you can get. If you reset this by giving a low enough voltage, it's going to hold the output low no matter what. Then you would just get the blue LED lit up. So we don't want it to do anything. It's the most powerful input right there. And let's go over the output again. When the output is high there, red LED lights up. Lower value resistor than the blue LED because it doesn't get as bright, plus there's a little less voltage. When it comes to the blue LED there, it's going to light up when the output is low right there, connected to ground, because you can see that path right there. So it's usually a lot brighter than the red LED, and also we have a better connection. It'll have more of the 5 volts across it right there. And so we are going to use a 1000 ohm resistor. Now let's move over so you can kind of see the circuit there. We have 2 resistors. Thanks to this diode though, they are not interrupting each other's timing right there. The timing is separate. So if we didn't have the diode there, the capacitor would have to charge through 2 10K resistors right there, and it would let's hold that there, and then it would discharge through just 1. So it would take twice as long to charge as discharge right there. So now we got the diode. When the output is low, then the current flows, because we're going to think of positive to negative, conventional current instead of electron flow. Then it goes around that resistor there and charges the capacitor. So a little current will trickle through, but vast majority of the current goes around and charges the capacitor. When it gets to 2/3 of the supply voltage, so that's when it's high actually. When it gets to 2/3 of the supply voltage, then it will discharge through the capacitor. That sets the output low as well through pin 7. So pin 7 is kind of like a switch. When the capacitor is charging, the output is high. Pin 7 is not conducting. It's just an open switch, nothing going in or out. So we just like ignore it. And then pin 6 sees that you got to 2/3 supply voltage, and then it discharges through pin 7 to ground right there. That's when the output is low. When it gets to 1/3 of the supply voltage, pin 2 senses that. So it's just, sensing the voltage. No current ever goes in or out of pin 2, other than like a tiny bit of leakage. And same with pin 6. Okay, so pin 2 sees 1/3 of the supply voltage. It sets the output high, turns off 7, and then the capacitor can charge again. So that's why it's astable mode. Either the capacitor is charging or it is discharging, but once it gets up to 2/3 supply voltage, then it starts discharging till it gets down to 1/3 supply voltage, then it charges, forever, as long as power is applied. So I'm not going to ramble on about that anymore. So again, there's the output. When it's low, the blue LED lights up. Of course, you don't need to use the low to do anything, and you don't need to use the high to do anything if you don't want to. It's just an output. That's all it is. It's either connecting as close to the positive supply rail as it can, or the negative. Usually you wouldn't use it to flash LEDs unless you really need flashing LEDs. Now we have, as I said before, 2 resistors on the way to the capacitor, but it can be bypassed through that diode right there for charging. So that way, and then it has to discharge because that's what the diode does. Lets current flow that way. Gray band is over here touching the capacitor, called the cathode. The anode is up above where the discharge pin is, pin 7, right above that jumper there. And then it discharges pin 7. So pin 2 and pin 6 are just tied together. They're both looking at the capacitor voltage right there. So I just got a little jumper that I made that I jumped across there. If you don't have a way to cut and strip the insulation off those, if you have a whole bunch of these breadboard cables, jumper cables right here, you can just take like a longer one and just bend it in the middle. That will work perfectly fine as well. So you can do that. Now, if we want them to go faster, then we could either use lower value resistors right there, one or both, depending on if you want to adjust the timing of them differently, or you could use a lower value capacitor. That would go faster. They could also all be lowered. Again, that'll go faster. You raise the values if you want it to take longer. So you can raise the value of, you know, any of them. It'll take longer as long as the other ones are the same. You know, if you really need to, you can raise the value of one, lower the value of another one, for whatever reason, and it's going to keep the timing close to the same. So that's how that works. I'm not going to show a lot of demonstrations on that. Hopefully that already makes sense. So that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.